Hello everyone, here is an interesting question that I got today. I want us to look at it together. It says that a ball of mass 2 kg dropped from a cliff, hits the ground 2 seconds later, and then rebounds to a height of 5 meters above the ground. If the acceleration due to gravity was 10 meters per second squared, calculate the momentum of the ball after the impact and the impact on the ball on hitting the ground. Let's look at this thing very well. The cliff is obviously above, the top of the cliff is far away from the ground. So let's say that, let's come this side. Okay, so this ball is going to strike the ground. Now, when it is released, anytime something is released from a height, you know that the initial velocity is going to be 0. So this ball is going to fall and hit the ground here. Now, it means the final velocity is not 0, okay? Because it's going to hit the ground with a velocity. It took how long? 2 seconds to fall down. And acceleration due to gravity is 10 meters per second squared. Let us calculate for this. Let's calculate this velocity. Now, look at the things you are given. This one is acceleration. This is time. This is v. I want you to look at these equations of motion and tell me which of them is suitable for calculating this v. See, we are not given height. Do you understand? They didn't tell us the height of the cliff. The only time they mentioned there is the height of when the ball bounces back, rises back up. They told us how far it went up, not how far that's the height from which it fell. They didn't give us, so no h here. Now, that means we can't use this one because this one has distance, which is height in this case. This one also has distance s. So the only one we can use is this one. So using this, we have that v, which is final velocity, is equal to what? U, which is 0, plus what is a, acceleration. Of course, we're using plus because it's falling under gravity in favor of gravity, right? It's not going against gravity. So we have gravity, acceleration due to gravity is 10 times time is what? Time is 2. So we have 20 meters per second. That is the velocity with which the ball hits the ground. Now, because of space, I'm going to clean these things. I want you to write everything down so that we can proceed. Now, when the ball hits the ground, we are told that it went back up. Okay? A height of what? 5 meters. Remember, acceleration is still 10 meters per second squared, but in this case, it's going to be negative because the ball is now going up against gravity. And we don't have time. We're not given how long it took to rise up to that 5 meters. Okay, the next thing we are given is, what else are we given? Of course, we know that when the ball rises up, the final velocity is going to be what? 0, because it's rising up. It comes momentarily at rest or to rest at the top. Then it's rising with an initial velocity which is not 0. You see that? So anytime an object is rising up from the ground, it has an initial velocity. Then at the top, when it gets to the top, that's when the velocity becomes 0. Now, which of the equations are we going to use? If you check those equations, you will see that this is the one that fits this. Why? Because we have h, which is distance, that is s. We have acceleration due to gravity, which is this one. We have v, which is this one, and u, which is this one. So we are looking for this u, the initial velocity, because we know the final velocity is 0. So we put 0 here is equal to, of course, you square it. Then u squared minus, you know why we're using minus? Because it's going against gravity. So write 2 times 10 times the height is what? 5, right? Good. So if you multiply all these things, you will get that, of course, 0 squared is 0, which is equal to, now let's make it faster. If you multiply all these things, it's going to give you 2 times 10 times 5, that is 100. And if you bring the negative 100 to the left side, it will become positive. So you have 0 plus 100, which is still 100, is equal to u squared. That means that u is the square root of 100, which gives you 10 meters per second. That is the velocity after hitting the ground when it was rising back. So the velocity with which it began to rise back up into the air is 10 meters per second. Now, let's now look at the question. First, it said the momentum after hitting, the momentum after the impact. Okay, I have a question for you. Remember, we got two velocities. We got the final velocity during the first motion, which was 20 meters per second. Then the initial velocity that the ball rose with in the second motion, which was 10 meters per second. So momentum means mass times velocity, right? So the question is, the velocity, remember they said after the impact, after. This one was at the moment it hit the ground. Then this one was when it was rising up. So this is the velocity after the impact. So we're going to use this velocity. Mass is what? 2 times this one is 10, which is what? 20 kilogram meter per second squared. This is the unit of what? Momentum. Second question, the impact on hitting, the impact on the ball on hitting the ground. Okay, here we're dealing with the impulse. Impact here means impulse. Okay, now impulse has two formula: force times time. Impulse also means change in velocity. Okay, however, I want you to notice that the velocity before, when the ball fell down, the velocity, if you take it to be plus, all right, then when the ball was going up, the velocity is going to be minus. So anytime the two movements are in opposite direction, change in velocity is written as mv plus mu. You understand? So this is going to be equal to, you factorize this and you get mv plus u. Okay, now we now add the two velocities. The mass is 2, okay? Then the first velocity that we calculated was 20. The second one was 10. So when you add 20 plus 10, you get 30. And 2 times 30 is 60. You understand? Now, what's the unit for impulse? This is force, and this is time. So it is Newton second. So that's the impact on the ball after hitting the ground.